Okay, welcome everybody. Good morning and good afternoon for different time zones. Welcome to this webinar, Seeing Pictures and Seeing Things. I'm Vittorio Gallese, the director of the Lab Neuroscience and the Humanities, which is hosting this webinar organized by Nicola, Bruno, and Alberto Voltolini. Just briefly to tell you something about the lab. The lab was founded just before all this COVID nightmare began, at the end of 2019, with the purpose of creating bonds between neuroscience and the humanities. And one of the things we do is organizing meetings. We hope to organize meetings in person. So far, it has been almost online events. With a few exceptions, we managed to present a few books in person here in Parma. So the idea is to foster mutual understanding, a dialogue, collaboration, the crossing of different perspectives, very much like we are about to do today. The topic is incredibly timely as we live in a world of images, even more so since the beginning of the pandemic. They are one of the key sources of knowledge. In Italian, we don't have this nice distinction between image and picture. We must rely on a paraphrase or rappresentazione pittorica. So I trust we will learn a lot about this fascinating topic from all the distinguished speakers that are here with us today. So with no much further ado, I leave the mic to the organizer, and I'll disappear. Thank you.
So just a very brief word as an introduction to the webinar, and I'm going to share just one slide with you. This is really how it all started. A few months ago, Vittorio Gallese posted an article about this mosaic, and Alberto and I responded to this article. We had a discussion about the differences between seeing dogs and seeing pictures of dogs. This is, of course, a picture of a dog, but you know what I mean. And that's how the idea for this webinar really came about. So here we are, and I wanted just to say what a great pleasure it is for me, and what an honor it is for me to do this with distinguished colleagues whose work I have followed and greatly admired over these last years. And I'd like just to thank, of course, the Laboratory of Neuroscience and the Humanities for its great work it's doing to promote research in experimental aesthetics, and also especially Nunzio Languilli for all the help that he gave with technical issues. So that's all I wanted to say, and we can begin, I think, with the first talk. So I'll just leave the microphone to Alberto, who will be chairing the first session. Thank you.
Okay, thanks a lot, Nicola. I won't add any more words since we have a very dense day today. We have about 12 speakers that we have squeezed in 3 different sections. So we will now have 4 speakers starting, and then a discussion of a quarter of an hour, then another 4 speakers and still discussion, and then the final 4 speakers and still another discussion. And then if we will have still time, we will have room for a final general discussion together. I will be, as a chair, very, very rigid because of lack of the time. So all the speakers have to remember that they have just 15 minutes. And when the 15 minutes starts, I will get into the talk and informing the speaker that the time is over. So without further ado, I leave the floor to the first speaker of today, who is Marco Bertamini from the University of Padua, who is giving us a talk on types of picture perception. Thank you, Marco.
Thank you. Let me try and share the screen. It was working when we tested it. Is it? Can you see it?
Mm-hmm. Yep.
Okay, thank you. There are different types of pictures. Not all pictures are the same. So I thought I'll start by distinguishing four types. Sometimes it's useful also because some of our disagreements otherwise may be because we are not talking about the same thing. So the simplest type is when we have lines, patterns, configurations, juxtaposed regions of different colors. You may recognize some of these examples. I include here also tessellations and mosaics. So these are clearly non-representational. The next one is representational. We have a scene with some layout, but they can vary very greatly in how they're produced and how they look. So here you have an example from a 4-year-old drawing. Then there is Giotto. This is the famous one where the halo sometimes is behind the head of the person, sometimes is in front. Then there is an 11th century tapestry. The point is that we do see some kind of scene with the space and layout. And in this category, I would include also these, which are studied a lot. And I would say these are also scenes with the layout, as long as we are seeing the surfaces in front of other surfaces. In the case of the Necker cube, we see that as a cube that is sitting on some kind of white surface. So in all of these cases, the key word, I guess, is layout. There is something which extends in space. Then we have anything that could be the projection on a flat surface, as in a photograph or Renaissance paintings, his Mantegna, an architectural drawing, a photograph from Robert Capa. The architectural drawing comes from the book by Michael Kubovi. Now we know that we can see distortions in this case, in at least two cases. One is when we misperceive the orientation of the surface, and the other is when the visual angle is too large, as in the second case here. And finally, we have a type D, if it moves on, in which we have three additional properties: realness, presence, and tangibility. I'm using the term realness here as it is used by Dhanraj Vishnavathi. We'll say more probably later. Basically means that we have a sense that something is there, we are there, we can touch it. Now, you might say, why is this picture perception? Maybe this is everyday perception. I think it's important to have this because all of these properties of realness, presence, and tangibility can be experienced even when, at least rationally, we know that we are looking at a picture or a monitor, like when we're wearing a head-mounted display. Also, these objects don't need to look realistic. And in the case of a mirror, we have all these cues that specify these virtual objects. We might have a sense that we could touch them, even though we know perfectly well that we cannot touch them. So there are all these properties can be present also while we are also aware of the surface of the picture as well. Now, I've listed this giving examples, but the stimuli are not enough to distinguish these four types. The viewing conditions are also critical. And depending on those different viewing conditions, the same stimulus might be moving from one category to another, and we can go both up and down. So in general, removing depth cues or adding cue conflict would push images down, and adding depth cues, removing conflict and moving to the appropriate vantage point may move us up. An example of this would be the use of the synopter to remove cue conflict. I have a footnote here, footnote number 1. If we think about the cues available and how these cues work for that visual system, we can understand also a lot of the differences between species in how they experience pictures. So a cardboard cutout, which has a very simple shape, as long as it is combined with movement, which is the critical cue here, if it moves to the right, the chicken ran away, they're scared. If it moves to the left, they don't. This is the famous Lawrence and Termagren experiment. End of that footnote. So here is now my main thesis, what I would like to say, which might be controversial. So a lot has been said about the difference between B and C, discover a linear perspective, and so on. Also, a lot has been said about realness, about sense of presence. But in terms of perception and perceptual processes and consequences of looking at something, I would argue that actually B already has a lot in common with C, with D, and with everyday perception. And the real difference is between A and everything else. So footnote number 2, so I will argue that realism is not important, and artists sometimes care about it, sometimes they don't. A long time ago, the person who created this rhino made it with a horn that is wrong in size and shape, not by mistake, probably, because he spent some time making a beautiful curve. It just wasn't important to make it look like a real rhino. Okay, footnote number 3. I'm not certainly claiming that as we move A, B, C, D, as we move up, that we increase beauty and aesthetic value. Indeed, there are some counterexamples to that. In the vista case, faraway mountains, or indeed the moon, we might say something like, wow, that looks like a picture. It looks like it's been painted. I actually have few cues there. It looks something lower as a category, lower than what we expected. We may find that beautiful. Now, I have 3 pieces of empirical evidence to support my thesis, and this is the first one. Suppose that we are going to look now at this very simple stimuli that are used in the literature to study amodal completion. As I said, as long as there is this segmentation and one is perceived as a surface in front of another, for me, that's already category B. But does that happen always? Is it a process that is slow, maybe? Maybe it's voluntary, maybe it's not, maybe it's effortful. Okay, so to answer that question, a long time ago, Secula and Palmer thought of a clever priming paradigm in which we are shown this type of configuration, but we're not asked anything about amodal completion. We just see whether the circle is perceived as a circle, because if it does, then it should prime the processing of a circle. And what I concluded was that that was the case. This was perceived as a circle, but only after 300, 400 milliseconds. So maybe at the beginning, we do see this as just juxtaposed regions of a configuration which would be the type A. However, here is where Q conflict becomes critical, and what has been seen in other experiments, also with the same priming paradigm, is that that conclusion was only true if we had that Q conflict of looking at the monitor with both eyes and have zero disparity. If the Q conflict is removed, then this process of amodal completion and separation of surfaces on one surface in front of another is actually very fast, automatic, and will happen for all kind of tasks where, you know, in these measurements don't require, there is no need for the participant to see the occlusion, but they will see it anyway. Sorry, I don't have the time to describe the paradigm, but I can if you ask me questions later. Second piece of evidence, boundary extension. Boundary extension is a phenomenon where when we see a scene, an image, could be a photograph, a drawing, or something else, we remember more than what was present in that image. We remember beyond the boundaries. And that could be true for long retention intervals, but also very short, like even just 200 milliseconds. And over the years, many experiments have been done. And what seems to emerge is that binary extension will happen as long as this is perceived as a scene with a layout and with space. So again, the critical distinction is between something which is just lines and patterns and regions that does not produce binary extension. Anything instead which is a scene that will produce binary extension. In this experiment, for example, you get good binary extension for the type of images, drawings on the left, which has a background, and you take away the background. If this is perceived as just something like a cutout stuck on a piece of paper, you don't get binary extension. If you invite people instead to imagine that this is an object sitting on a white surface, then you can get back binary extension. Now, although this has not been done really systematically, from enough experiments, we have enough experiments using enough different stimuli to see that binary extension does not require anything above type B, so anything that is perceived as having some extent, and anything else, including in this particular study here, looking at real objects in everyday perception. So that was the second piece of evidence. And here's the third piece of evidence. So I'm now going back to mirrors, but now it's not what we see inside the mirror is a representation of or a scene described as having a mirror in it. And when that is the case, that way of presenting the information can vary a lot. The first one at the top is a Roman mosaic, so there is no real perspective yet here. The second one is a photograph, and we've done also experiments with actually looking at rooms with people. And in all of those cases, there is a strong tendency for people to say, as long as there is a mirror represented and a person represented looking in the general direction of the mirror, that is enough for them to say, she is looking at herself. Okay, so this is the Venus effect. It happens for all types of images, including type B. So again, it's another case where type B already produced the same response as C and D and everyday perception. Because we are talking about mirrors, if we talk about the virtual objects, that is indeed a good example of a sense of realness and presence and tangibility, which means that there is strong shape and size constancy, which means that when we ask information about what is on the glass surface, that is information is not accessible to people. So we can't believe that our head is half the size of our head if we were to outline it on the glass surface. Unless we outline it with a pen, even in front of a mirror, we find it hard to believe. And we have shown that in many experiments in which we went to great lengths to explain to people, look, now we want you to judge the distal object in one condition. In another, we said, no, now we just want you to judge what is on the glass surface if you were to outline it on that surface there. And therefore, in front of it, they can certainly judge how far the glass is and so on, but they still make large mistakes when they're asked to judge what's on the glass surface, producing responses that are much closer to the actual object. And that was, in that sense, the mirror and a window are exactly the same. So in summary, overall, picture perception of type B and above includes image segmentation, depth stratification, A-model completion, memory extrapolations. A lot of interesting processes are happening as long as what we look at is perceived as a scene with some layout. It does not have to be realistic. So realism is not important. And so in many ways, even simple pictures of type B lead to a form of picture perception that has already much in common with everyday perception. Now, that claim might be controversial. I might be in a minority at this meeting, maybe a minority of one. We're going to see. I'm going to just use the five last seconds to summarize all of this. Actually, I'm not summarizing all of it myself. Buster Keaton is going to do it for me. Hopefully, you can see the video. It's not going to be a problem on your screen. So it's going to go all the way from a line, which is just a line, to something we can interact with. So he's painting a hook on the wall, but then we can hang a hat to it. Thank you very much.
Okay, thanks a lot, Marco, also for having respected so strictly the times. So we now move to our second speaker, who is Robert Briscoe from the University of Ohio. Robert is giving us a talk on pictorial experience and ordinary seeing. Please, Rob, the floor is yours.
Sorry. Can you see my talk?
Yes.
Yes.
Okay, great. All right, so the term picture as used in everyday speech refers to a broad heterogeneous class of artifacts. As understood for the purposes of this talk, however, pictures are specifically those two-dimensional surfaces marked or otherwise designed to elicit experiences of depth and visual three-dimensional structure from their intended viewers. In what follows, I'm going to briefly make the case for the view that pictorial perception is psychologically continuous with everyday seeing, and I'll then focus on an objection based on the idea that pictorial perception, unlike ordinary seeing, has a twofold phenomenology and representational content. In contrast with ordinary seeing, pictorial perception on this view is structured by simultaneous awareness of the picture's opaque two-dimensional surface and the three-dimensional object or scene displayed by that surface. And this is the view familiar from the writings of the philosopher Richard Wollheim. In reply, I'm going to provide some reasons to think that the supposed twofoldness of pictorial perception may be based on a kind of cognitive error. Okay, so when you look at Gustave Caillebott's painting Paris Street Rainy Day, two conflicting sets of depth cues are typically available to your visual system. At close range, binocular disparity, vergence, motion parallax, and accommodation specify the orientation of the painting and its distance and depth from us. The structured ray of light reflected from the painting's surface, however, also conveys numerous sources of spatial information that jointly specify the layout of objects in a virtual, three-dimensionally organized scene. All right, so some examples, and these are the kinds of examples you'd encounter in a vision science textbook, include occlusion, texture gradients, shadows, reflections, specular highlights, relative size, familiar size, linear perspective, atmospheric haze, height in the visual field, and the horizon ratio. And if we had more time, we could look at this nice painting and show how each of these cues is used by the painter to elicit a very rich experience of depth and three-dimensional structure in a full-blown three-dimensional scene. Now, to the extent that pictures in real-world scenes can cause the same types of information-bearing proximal stimulation in their viewers, they can also cause their viewers to form perceptual states of the same types of object and scene representing content. Information that would cause the representation as of an object with certain properties when present in the light reflected from a real-world scene will cause the representation as of an object with the same properties when reflected from a pictorial surface. In the first case, the result is more or less vertical object perception. In the latter, the result is what Tyler Burge, the philosopher Tyler Burge, calls perceptual referential illusion. That is, perceptual representation as of an object in the absence of an object that's successfully represented. Consistent with this, vision scientists often assume that the same mechanisms of figure ground segmentation, feature binding, object-based selective attention, and other capacities for visual singular reference can be engaged by information in the light reflected from a pictorial surface as by sources of depth information available when reviewing a real-world scene. Indeed, empirical studies of these capacities typically exploit the methodology of picture-based or virtual psychophysics, as Jan Koendrick calls it. Okay, so pictures, unlike the scenes they depict, are opaque two-dimensional surfaces on a single plane of depth. And the question arises, awareness of the picture surface related to our experience of differentiated depth and three-dimensional structure beyond that surface in pictorial space. One view is that pictorial experience has two dimensions or folds of representational content, where one fold represents the two-dimensional configuration of features on the picture plane, and the other represents the three-dimensional scene displayed by those features in pictorial space. And crucially, we're both of these folds at the same time. So that's Richard Wollheim's view. Each fold, we could say, corresponds to a different interpretation of our retinal image when we look at a picture, a different hypothesis, so to speak, concerning the most likely distal cause of retinal stimulation. Twofoldness has been taken to challenge the assumption that the experience of pictorial space is psychologically continuous with ordinary seeing, and hence to challenge the methodology of picture-based virtual psychophysics. But it also seems pretty paradoxical. Part of what makes opaque objects opaque, John Klevicki writes, is that they occlude one's view of things beyond them. The experience of looking at a picture is paradoxical in that it presents more than one opaque object before the viewer in a given direction. In contrast with ordinary seeing, pictorial perception thus fails to present a single, consistent, three-dimensional scene interpretation of the retinal image. All right, so to illustrate, imagine that you're looking at Vincent van Gogh's painting of his bedroom here in the upper left-hand corner. There are at least two different ways of interpreting the edge inside the yellow frame here. So first, the visual system could interpret the edge as a surface event. For example, as a reflectance edge or a cast shadow or a crease. So that's one way of interpreting that edge in our retinal image when we look at the picture. Alternatively, the visual system could interpret the edge as the contour of a background occluding object. And on this interpretation, one side of the edge is at the depth of the object, while the other side of the edge is at the depth of the partially occluded background. All right, so part of what it means to claim that pictorial perception is twofold is that we're consciously aware of both of these interpretations at the same time. And if this view were right, then clearly pictorial perception would have a very different structure than ordinary seeing. According to a different view, and this is a view that most of you are probably familiar with from Gombrich's book Art and Illusion, we're able to switch between these contrasting interpretations, at least under certain viewing conditions, and something like the way we alternate between different aspects of an ambiguous or bistable figure. The example that Gombrich uses in this connection is the duck-rabbit figure. So here's that diagram we looked at before. The main difference between Gombrich's view and Wollheim's is that for Gombrich's, both depth interpretations of this edge in our retinal image are possible, but not at the same time. We alternate, or as Gombrich puts it, we oscillate between them. So we can interpret the edge as a surface event. We can interpret the edge as the occluding contour of an object in pictorial space, but we can't interpret the edge in both ways at the same time, or at least we can't consciously experience both edges, but both interpretations of the edge at the same time. So it's very difficult to adjudicate between these different views of pictorial experience on purely phenomenological grounds. And what follows, however, I'm going to do some considerations consistent with the idea that twofoldness is actually a kind of cognitive error rather than a phenomenological given. So first, the supposed twofoldness of pictorial experience might be motivated in part by a kind of immanence or refrigerator-like illusion in which you mistake the potential presence in visual consciousness of a property or set of properties for its actual presence. In particular, our ability to switch without any significant delay between the colors, textures, and other properties visible on a picture surface on the one hand, and the properties of the three-dimensional object or scene displayed by that surface on the other, might contribute to the illusion that both sets of properties are present in visual consciousness at once. All right, so that's one way in which twofoldness could rest on a kind of cognitive error. Second, when a Gombrichian switch between competing interpretations of a picture's retinal image is possible, iconic and/or visual short-term memory of pre-switch interpretations may support the illusion of simultaneity. For example, instead of simply alternating between the experience of the pattern of brush strokes on a two-dimensional canvas, that's interpretation A, and the experience of an object or scene in pictorial space, that's interpretation B, the viewer may alternate between interpretation A combined with a conscious visual memory of B, and B combined with a conscious visual memory of A. So there's an oscillation, but the oscillation is a little bit more complex in its structure than the one that that Gombrich describes, since it includes a visual memory component. And in consequence, the viewer may deceptively seem to enjoy both experiences A and B at once. All right, so that's a second way in which twofoldness might rest on a kind of cognitive error. Third, some cases of pictorial perception may involve the phenomenon of scission, in which the visual system segments surfaces at different distances in depth along the same line of sight. For example, the visual system may assign a certain glossiness or texture to the two-dimensional pictorial surface, perceived of as in front of and transparent to an object behind it in pictorial space. And I think this painting on the right here illustrates this phenomenon fairly well. We're aware of what looks like a woman in pictorial space, but at the same time, we're aware of the picture's glossy surface. We're aware of the highlights and the texture of the paint strokes or the varnish on the pictorial surface. So this would be a case in which pictorial perception attributes certain properties to the two-dimensional pictorial surface and to objects in pictorial space at the same time. But precisely because the surface is perceived as transparent, it provides no support for the idea that pictorial perception exhibits twofoldness in Wollheim's sense. Fourth, in some cases, pictorial perception could involve conscious representation of a picture surface, but in an unusually indeterminate kind of way. In particular, it could represent the absolute distance and orientation of a surface, as well as some of its geometric properties, for example, its curvature, its shape, its size, while not attributing any color properties to it. Just as the visual system does not offer comment on the absolute distance of objects embedded in pictorial space, and this is something that the Donraj has written quite a lot about, it may not offer comment in some cases, I'm suggesting, on the colors present on the pictorial surface. To be clear, I'm not suggesting that in relevant cases we experience the pictorial surface as transparent to the three-dimensional scene it displays. Recall Metelli's constraints on transparency perception. If all the color goes to the transparent layer, it becomes opaque. If all the color goes to the underlying surface, then the transparent layer becomes invisible. Transparency is perceived only when there is a distribution of the stimulus color to both the overlying layer and the underlying layer. In the type of experience that I'm characterizing, however, there is no distribution of color across layers. Instead, all the color goes to the underlying layer, that is to the object or array of objects in pictorial space. But this doesn't entail that the pictorial surface is invisible like a perfectly clear pane of glass. Instead, we may visually experience the surface in a highly indeterminate way, as present at some absolute distance in depth and as having such and such orientation relative to our line of sight, but not as having any color properties of its own. If so, there would be no inconsistency internal to an experience that represents both the surface and non-veridically a three-dimensional scene receding in depth behind it. This description, I would suggest, fits the experience of looking at certain photographs and naturalistic paintings, especially at a distance, as well as the experience of watching movies. In the normal case of watching a movie, Colin McGinn writes, we don't focus our attention on the fleeting patterns of light. We, as it were, look right through them. Again, this doesn't mean that visual awareness of the surface drops out entirely. The color properties we experience when we watch a movie are assigned by our visual system to objects, so to speak, on the other side of the screen, but we're still aware of the screen's presence and typically have no difficulty estimating its distance from us or its orientation. All right, so to wrap up, in this fourth kind of case, like the case of transparency perception discussed earlier, it's possible to mistake our joint awareness of the pictorial surface and pictorial space for a case of twofoldness. The pictorial surface, after all, really is an opaque two-dimensional array of features, and we know it to be such. Since in both relevant contexts we are aware of the surface's presence, we may impose this knowledge on our description of the phenomenology of our experience. The result is a conception of pictorial perception as twofold that is partly based on introspection, that is, on our genuine awareness of the pictorial surface, but that fails to capture the way the surface is actually represented in visual experience. In one case, as transparent to objects in pictorial space, and the other as indeterminate or silent with respect to color. All right, so that's it.
Thanks a lot, Rob. Now it's time for us to have a talk by the third speaker, who is actually also one of the organizers, Nicola Bruno from the University of Parma, who is giving us a talk on the ways of seeing perceptual referral in pictures. Nicola, please.
Thank you, Alberto. So I'm concerned with this question, okay? Seeing pictures and seeing things, what is the difference between these two things, these two ways of perceiving? And as you all know, there's been a lot of debate both in perception and in philosophy about something that we may call the duality of perspective paintings. You've already heard about this. When we see a perspective painting, we perceive both a flat surface, the canvas, and we perceive a represented scene in depth. And people have been debating whether this is due to two processes or maybe two experiences, the twofold theory, or whether pictorial perception is just a special case or continues with ordinary perception, and twofoldedness really only has to do with a certain kind of conflict between different types of sensory information. Now, on this, I'm not going to comment much more because you're going to be hearing about this debate again and again in other talks. So I'd like just to say that I've never been too impressed with this way of framing the problem for a number of reasons that I can't really discuss in full here, but perhaps the most important reason for me is that while I can usually use these conceptual tools to talk about a painting like this, where it's a perspective painting, it's clear that it's representing depth, I really cannot apply it to a work of art like this, or a picture like this, or like this, or even something that is a little bit more representational, like this one, or this one. And I think you know where I'm going at, but for this reason, the task that I try to set for myself in this talk is to try to present maybe a different way of thinking about this problem. What are pictures and how do they differ from real objects when we perceive them? And so this is my thesis, really, my proposal. Okay, it's not a full-blown theory, of course. But maybe, it's a few ideas that may help to set up a framework which is a little different for thinking about these issues. So I think we should start really by asking ourselves what is perception and what is visual perception specifically. And to me, three things are important. First of all, perception to me is a form of active exploration. So perception is something we do, not something that happens to us passively. And this type of activity is a form of exploration that has a purpose usually. It seeks specific information which is specific to the task that we're trying to achieve, to do. And also, critically, this kind of visual explanation establishes some kind of relation between the viewer and an external entity. And I call this referral. And of course, it's related to age-old ideas and problems in philosophy about meaning, about reference, intentionality, and so on. But let me just explain what referral is by suggesting that this actually leads me to claim that there are three different ways of seeing. The first way achieves distal referral, and this is what we do when you're seeking information about external entities. The second one, I suggest we may call proximal referral, and this is what happens when we're seeking information about your own act of perceiving process in relation to these external entities. Just to give a simple example of this distinction, think about what happens when you're touching an object with your hand. Okay, you can focus on the shape, the size, the position of the object, or you can focus on where on your skin you are touching the object, whether it's the index finger, the palm, and so on. In vision, the same thing happens when you are looking at things and you're focusing on things outside, or when you are focusing on how they relate to your own viewpoint. So it's a little bit like what painters do when they're trying to copy, right? To make a drawing from reality. They have to pay attention to things like visual angles, positions in the visual field, and so on. But then there's also a third kind, I think, of referral, and this is when we're seeking information about mental states of other organisms, when we're trying to perceive intentions, when we're trying to perceive emotions, the meaning of other people's actions, and so forth. So what I'm suggesting is maybe we should analyze not only pictures, but also the way we explore pictures, what we do when we are perceiving pictures and things. And in this, I think it's useful to also recall a couple of other concepts. One is Gibson's attempt to classify action systems. When we talk about perception and action, we often imply that action is just one thing, but in fact, there are many different ways that we act, that we perform movement with different aims, and presumably, I think, in recruiting different systems. So Gibson claimed that there are 7 different action systems. The most important, I think, to this talk are the last 3, which are in bold here. Orienting, investigating, which is, proper perceptual exploration proper when we move eyes or the head or the whole body to change our viewpoint and get new information. But also important, I think, are what Gibson called the expressive and the semantic systems, which have to do with facial or postural movements that give out our emotions, and semantic system, which is everything that has to do with gesturing and speaking. Another thing that I find useful to consider within this framework are a couple of notions by Daniel Berline. Berline had this interesting idea about curiosity as being a sort of mental state that motivates exploration. And he made a distinction between epistemic and perceptual curiosity, meaning that curiosity can happen at the conceptual level when we see some kind of conceptual or ambiguity or conceptual complexity in a stimulus, and it motivates us to seek for solutions or to test hypotheses mentally to understand this conceptual complexity. Perceptual curiosity, instead, is motivated by sensory complexity or sensory ambiguity, and it motivates perceptual exploration, for instance, by eye movements. And in a later book, Berline used this as a starting point to develop a theory of exploratory behaviors that also makes an interesting distinction between specific exploration and diversive exploration. Specific exploration being what is aroused by some kind of curiosity, conceptual or perceptual, or both actually at the same time, and involves exploration in depth to acquire novel knowledge or sensory information from the stimulus. And it tends to happen when we are confronted with the situation that is rich in information. Diversive exploration, instead, is novelty seeking. It involves global exploration to arouse curiosity, most likely when there is limited information in the stimulus. So it's a little bit like, you're bored about what you're seeing, so you seek something new, and based on this, I'm going to try to attempt and conclude an answer to this question. So within this framework, when we see things, when we do ordinary perception, we are engaging only one kind of referral, distal, proximal, or social, at a time. And we can switch very much like Robert was saying earlier, focus from one to another by attention. And this also guides a specific exploration, either within the orienting investigating system through eye and body movements, or through the expressive and semantic systems through some kind of internal motor simulation or mirroring, if you wish. When we see pictures instead, something different happens, and I am sort of offering the idea that pictorial perception may be unique in that it engages all three kinds of referral at the same time. We are referring to the picture as an object in the environment, the canvas, the flat surface, but we're also referring to the picture as it appears to me from a given viewpoint. And thirdly, we also refer to the picture as a vehicle of communication, so we perform social referral as well. So that's in essence threefold referral, and I am suggesting that this will engage both the orienting investigating system and the expressive and semantic systems at the same time, and stimulate us to perform both specific and diversive exploration. And that's in essence the threefold referrals framework, which of course also raises a number of different questions, like for instance, is this heuristic? What kind of evidence would you need to gather to falsify these ideas? What's the contribution to the philosophical analysis of pictures and others, such as, I don't know, for instance, individual differences or pictures that were created randomly by some kind of natural formation rather than by an artist. But of course, we don't have time now to go into these questions, and I will leave them perhaps for the discussion. And so that's it. Thank you very much.
Thanks a lot, Nicola. And now we are going to have our fourth speaker of the first quartet, who is Fabrizio Calzavarini from the University of Bergamo, who is giving us a talk on real objects and pictures in visual agnosia. Please, Fabrizio. Fabrizio, you are still muted.
Sorry for that. So thank you. So I was saying that the object of my talk will be quite modest. So I'm just going to put on the table some empirical data that I assume that at least some of you already know it. But there are some interested that, according to me, should deserve more investigation. And then I try to suggest some potential future directions for experimental research and also some potential implication for current philosophical theories of pictorial perception. Okay, so we all know that visual agnosia is a deficit in visual recognition associated typically with bilateral damage to the occipitotemporal cortex. And it is also known that surprisingly, although patients with visual agnosia show severe impairments in recognizing line drawings and pictures of objects, they nevertheless show striking improvements when the same items are presented as real-world tangible objects. This phenomenon has been called the real object advantage in visual agnosia and has been documented in numerous case reports over the past 40 years. Now, these data are interesting because at least prima facie they seem be in tension with the continuity hypothesis, with the idea that pictorial experience and seeing face-to-face are experiences of the same psychological kind. Because we got here at least one side of a functional dissociation. We got pictorial perception impaired and perception of real object preserved. But indeed, the consistency between this data and the continuity hypothesis, it depends on what are the psychological mechanisms behind the real object advantage. And surprisingly, there are very few studies that have experimentally assessed the causal basis of the real object advantage in visual agnosia, with a total of only 3 patients assessed. A couple of early studies, and particularly this one that I assume that most of you already know, by China and Humphreys, published in 2001, have pointed to the relative importance of depth information provided by the stereoscopic disparity in motion parallax to explain the real object advantage. The author tested the patient AJYA, a very famous patient, the history of visual agnosia. They asked the patient to identify real objects and pictures, either positioned at a close distance or far egocentric position to manipulate stereoscopic disparity, and to identify objects and pictures with head position either free to move or fixed in a chin rest to manipulate motion parallax. And they found that the real object advantage was present with either stereoscopic disparity or motion parallax were present, but the recognition of the real object dropped at the level of the picture with both of these depth cues were absent in the fixed distance condition. And so based on this, the author concluded that, well, the real object advantage has to do primarily with that information, with the fact that patients with visual agnosia, as normal subjects, normally view real objects under condition which they got added more depth information from monocular disparity and motion parallax, which is usually absent in picture perception. Now, one might say that this conclusion doesn't threaten the continuity hypothesis, because we got here just a quantitative distinction, a distinction in the amount of depth information provided by pictures and real objects, but not a distinction in the kinds of cognitive processes involved in pictorial versus ordinary perception, or in the theoretical framework needed to explain these two processes. However, there is a much more recent study that I want to focus on in this brief talk that has been published nearly 20 years later than the previous one. So for 20 years, we got no experimental investigation of the real object advantage in visual agnosia that challenges the conclusion that depth information per se is what motivates the real object advantage. The study has been published by Holler, Berman, and Jacqueline Snow on cortex, and they tested 2 patients that, again, are quite famous in the history of visual agnosia, patient EF and patient JA. They asked this patient to recognize items in different formal conditions. So on one hand, real tangible objects, on the other hand, high-resolution bidimensional images, and also, maybe for the first time, they ask visual agnosia patients to recognize three-dimensional stereoscopic images. And then the depicted objects were matched with the real objects for a lot of parameters, such as retinal size, orientation, background, illumination, also apparent distance from the observer, and so on. The author manipulated the availability of depth information by motion parallax and binocular disparity as the previous study. But then critically, and that's the key element of the study, they also manipulated the size of the items, both real objects and images, relative to their expected size in the real world. So both real objects and picture could be congruent in size with the real objects in the real world, or could be incongruent, meaning significantly larger or significantly smaller. And briefly, what they found that, well, they confirmed the real object advantage, so the recognition of bidimensional, even three-dimensional pictures were severely impaired in such patients, but the recognition of real objects were strikingly preserved. But that's the critical finding. So the real object advantage was apparent only for congruent size real objects. So meaning that the recognition of incongruent size real objects, significantly larger or significantly smaller, were severely impaired and similar to the case of the images. And the size manipulation had little, if any, effect on the recognition of images, also the three-dimensional images, and also in the recognition of unfamiliar objects. So one thing that I didn't say that the author manipulated the size not only for familiar objects, but also for unfamiliar geometrical shape. Okay, so from this data, the author concludes that the real object advantage has not primarily to do with information, with depth information per se, but rather with information about the physical side, which is present, which is made available by perception of real objects, but not of images. And the idea is that when shape process is impaired, as in the case of visual agnosia, the size information, the size cues might provide critical top-down information that facilitates visual recognition. Now, the implicit, also explicit suggestion by the author is not that size information per se is critical for the real object advantage, but rather is the fact that perception of congruent size real objects, as opposed to pictures and incongruent size real objects, trigger an implicit activation of potential actions, so-called affordances, associated with familiar tangible real objects. So the idea that these patients, visual agnosia patients, recognize better congruent size real objects because they are the familiar objects that they regularly pick up and have well-developed motor routines. What we are talking about what psychologists sometimes call stable versus variable affordances, so potential access associated with familiar objects rather than motor action planes triggered by any kind, also unfamiliar objects. So the idea by Holler and colleagues that the real object advantage has to do primarily with the idea that pictures of objects, even three-dimensional images, do not offer genuine affordances, as in the case of real objects. Neuroanatomically speaking, Holler and colleagues suggest that it is very likely that the real object advantage in visual agnosia has to do with the dorsal stream, which was largely preserved in patients DF and JY. And the idea is that the dorsal stream encodes size and also motor and perceptual representation for the real objects, but not for the pictures. And that this kind of representation facilitates visual recognition either via connection with the impaired intrastream or operating in a standalone manner with the dorsal shape representation. Okay, so that's enough for the empirical review. So there are this interesting phenomena, a real object advantage in visual agnosia, very few experimental investigation, early study point to depth information per se, some most recent study, which I think they are quite interesting, very interesting, point to the importance of size information and indirectly, at least, to the perception of afford that is made available by pictures and not by objects. Okay, so this doesn't mean indeed that this explanation of the real object advantage that has to do with affordances perception is conclusively established. We, of course, need more research. This is just a couple of suggestions for further empirical research. We can indeed try to test the patients with visual agnosia using a transparent barrier, which is a common manipulation to decrease the affordances activation. So if this hypothesis is correct, then we should expect that the real object advantage is reduced or eliminated when a transparent barrier is placed between the patient and the real objects. And we may indeed look at assess the recognition of size congruent versus size incongruent familiar objects and pictures in patients not only with ventral lesion but also with dorsal lesions, and particularly it is known by neuroimaging research that the so-called stable affordances are preferentially encoded in the ventrodorsal as opposed to dorsal stream. a set of regions that are usually affecting the limb apraxia. So we might test limb apraxia pictorial perception in this patient to see whether the real object hand vantage is decreases or eliminated. And then we might use indeed more realistic images, such as also the use of virtual reality to see whether in visual agnostic patient this real object hand vantage disappears or is reduced in such situation. So what are the implications for the current philosophical theories of pictorial perception? I must admit that this is really an open issue for me, so any suggestion is welcome. So my initial guess is that this data seems to challenge any theory that endorses some version of another of the so-called continuity hypothesis. And particularly, this data seems to challenge the theory that endorses the continuity hypothesis for the computation of the dorsal stream in respect to to perceiving real objects versus pictures. I'm thinking here particularly about a recent amendment, an interesting recent amendment of the so-called Matte-Nanai account of ventral dorsal perception that has been proposed by Gabriele Ferretti. So, as you know, according to the Matte-Nanai account, one of the critical differences between pictorial perception and ordinary perception is the fact that the dorsal stream is activated for the real object, but not for the depicted objects. And this assumption has been challenged based on empirical data by Gabriele, who argued that the depicted objects, particularly when they are placed in the peripersonal space, apparently, and they are apparently graspable by the subjects, do induce the very same dorsal representation of affordances than the real objects. And connected to this, Gabriele has also argued that it is the ventral stream and not the dorsal stream that discriminates between real objects and pictures. So the dorsal stream does not distinguish between depicted objects and real objects. So at least prima facie, it seems to me that these data that I review here are in contrast with this idea. So clearly, if the explanation of Holler and colleagues that seems to be suggested by Holler and colleagues of the real object hand vantage is true, then the dorsal stream does compute potential action from the real objects, but not for the pictorial object. That's what explains this striking behavioral dissociation in visual agnosia patients between pictorial perception and real object perception. And that's the case also for three-dimensional images, so that images that apparently give richer depth information and also information about the apparent distance from the observer. This is not the focus today. This is consistent with this hypothesis is consistent with a lot of other empirical data. I want just to focus on patient data, but just to mention an example, there are a couple of interesting recent ERP studies that have suggested that perception of real objects as opposed to a perception of pictures elicit a stronger neural signature of motor preparation in the dorsal stream. And that's neural signature is modulated by a transparent barrier, so in accordance with the idea that affordance is activated for real objects, but not for pictures. And also the idea that the dorsal stream doesn't discriminate between real object and the depicted object is challenged by this idea. So it doesn't seem the ventral stream who is responsible for this behavioral dissociation between pictorial perception and real and ordinary perception, because the ventral stream is indeed largely damaged in visual agnosia. And if Holler colleagues are right, it is the dorsal stream that computes the difference between real objects and pictures. And this, again, is not a focus, but is consistent with a lot of other studies, such as, for instance, MVVA study that have demonstrated that the neural activity in the dorsal stream does discriminate between real objects and pictures. And again, this is at least some evidence in support of the idea that one of the key differences between ordinary perception and pictorial perception relied on the perception of affordances. Okay, that's enough. Thank you very much.
Thanks a lot, Fabrizio. Now it's time for the first break and the quarter of an hour of discussion. I see Vittorio raising the first hand and then Marco.
Yeah, thank you so much. I appreciated all the talks. I have a brief question for Calzavarini, the last speaker. indeed, there is evidence that even bidimensional images, for example, of tools, when perceived by people lying in the scanner, evoke the activation of the ventral part of the dorsal screen, namely the intraparietal area and premotor areas in the frontal cortex. And I think Corrado has more to add on this topic, as he used these images in some of the experiments he probably will be talking about. So my question for you is, how do we reconcile this mixed evidence about the fact that the dorsal screen apparently, as suggested, only deals with real objects but not with their representation? Thank you.
Thank you very much. A very interesting question. I'm aware of all this empirical evidence suggesting that also depicted objects, at least in dorsal cortex activation. So here probably a couple of possible explanations. First, well, it seems just one. So it's probably the only explanation that we got a difference in this aphodasis activation. So probably the real objects evokes much more intense dorsal activation with respect to pictures. So that's also consistent with, for instance, for the ERP study, they have found this neural signal for real objects much stronger for real objects than for pictures. What seems to be, at least if this hypothesis about the real object habitat in visual agnosia is correct, it seems to be that the functional profile of the aphodasis activation for depicted objects and real objects is different, because in the case of real object, this representation could facilitate visual recognition, and in the case of picture, does not facilitate visual recognition. But indeed, as I said, I think that we need much more evidence to support the hypothesis, this explanation of the real object habitat, and the kinds of suggestions for further research are in line with this direction. So that's, I'm aware that that's a, sorry.
Thank you.
Thank you.
Okay, Marco Meneghelli.
Hi to all. My question is to the second talker and the fourth one, Fabrizio and Robert.
Starting that you just ask one question.
Yes, yes. The question is starts from the problem of agnosia. My question is very simple, and the relation between perception and memory, looking at memory in a Kantian sense, as a sort of anticipation of perception, looking to the flash forward and the flashbacks of memory. So memory, the continuous hypothesis, the continuity hypothesis is related to the problem of psychological. We never perceive our perception continuously. It's a sort of Kantian hypothesis to the quality of perception, the quality and the quantity, intensive quantity, said Kant, wrote Kant. The continuity is the hypothesis of the mind to perceive. Psychologically, in a phenomenological sense, we anticipate many times perceptions, and at the same time we remember our perceptions. We never be in present with perception. There is no intuition, an immediate intuition, saying it with Peirce and Kant. It's always a mediation between instances of mind and memory. So the question to Robert in particular is the relation between memory and perception in a phenomenological sense, not regarding introspection, but only a phenomenological analysis of mind. Thank you. I hope to have been enough clear in my question.
Okay, Robert.
Immanuel Kant.
Well, I'm not super familiar with Kant. I'm not sure that I fully understood the question. There are different types of memory, and there's certainly visual memories. I think the content of a visual memory can significantly overlap with the content of a visual experience. In some sense, the visual memory is a record of the content of that visual experience. But I don't have much more to say than that, I'm afraid.
Okay, Robert, it's now your turn to ask a question.
So this is more of a comment than a question on Fabrizio. When I talk about the continuity hypothesis in my own writing, the main idea is that pictorial experience is continuous with ordinary seeing, in the sense that pictorial experience doesn't essentially involve sensory imagination, as some philosophers have claimed. It doesn't involve propositional imagination in the way that Kendall Walton claims. It's not a kind of cognitive state generated by a process akin to reading the pictorial surface, and it's not a sui generis kind of experience of the kind that Walton claims it is. The claim is really that pictorial experience is a genuinely visual perceptual state, and that seems true even if some properties are easier to perceive when we are looking at an object face to face, a picture of that object. So it may well be the case that affordances are easier to perceive when we look at a real world object, but I don't think that would challenge the main idea of the continuity hypothesis, which is that pictorial perception involves a genuinely visual perceptual state as opposed to some form of imagination or a state that's cognitive as opposed to perceptual in nature. But that's the only thing I wanted to say.
Yes, I agree. If you understood it this way, this data doesn't challenge in understood this way. Just the point is that, well, exactly the same psychological mechanisms are involved in real world and ordinary perception. If understood in that way, indeed, this data challenges, because, well, the idea is that not only we perceive affordances, but these affordances influence the very same visual recognition, which appear to be something that is strictly visual. So that was the idea.
Yeah,
but
I mean,
indeed,
with respect to physical size, I mean, I think someone like Donraj might say that, you know, one reason why we don't perceive an object's physical size when we look at a picture of the object is that absolutely scaled depth information is unavailable. And so you know, that's the crucial thing, and that's acknowledged to be absent in the case of picture perception.
Yeah. In fact, the author said that depth information is indeed critical, because it's thanks to depth information that we provide access to the size information. But it is the size that, according to this hypothesis, that explains the real objects, and not depth information per se. So thank you.
Michael Kubovi.
I have a question for Robert. Robert, your claim that there's no simultaneity of perception. I think you argued that there's a presence of the percept and a visual memory. But it seems to me that that doesn't quite weaken the duality claim, because I don't think that the duality claim is a simultaneous perception, but rather one sets the stage for the other. It's like expectations tell you something about what you're about to perceive and will influence the likelihood that you will perceive one thing or another. So it seems to me that the expectation that you're looking through a flat surface is the issue at hand and not the simultaneity of two percepts.
So that might be another sense in which pictorial experience has a dual aspect, and I don't know that I'm in disagreement with you. I see myself in disagreement with Richard Wollheim, who doesn't really talk about stage setting in the way that in quite the way that you just did. But I certainly think that it's the case that awareness of features on the pictorial surface can prime us or set us up to perceive certain features in pictorial space, and it can go the other way around. I mean, I think the organization of the pictorial surface, which we typically take for granted, you know, our ability to segment the surface into outline shapes, that's entirely dependent upon our perception of layout in pictorial space. So it's sort of looking through a window and tracing the shapes of the objects you see on the clear pane of glass. So in that way, it's certainly the case that perceiving depth in three-dimensional structure in pictorial space sets us up to perceive the organization of the surface.
James Cutting.
Yes, this is for Robert as well. I'm sure I misunderstood something, but I have what is likely to be quite a stupid question. It struck me that you were building what I thought was a rather seductive view of the surface being a kind of luminance domain and the substance behind the surface in the picture being in the chrominance domain and color. And I'm just the simple question is, what about black and white pictures or black and white movies?
Well, could you say more about why you thought that I was?
Oh well, I thought that the your talk about the surface domain being in terms of lightness and darkness, and the picture itself being about color. The content behind the picture.
Yeah, so
I think I've misunderstood.
Yeah, I'm not sure that I said quite that. I mean, I think there's. I mean, I think the view that pictorial experience is twofold is connected with the idea that in ordinary visual experience there are two modes of awareness. There's a proximal mode and a distal mode. And in art and illusion, Gombrich really sees the twofold theory as a sort of special case of the idea that in everyday seeing we can pay attention both to, you know, the manifold of you know, luminances in our retinal image and to a three-dimensional world of colored objects at the same time. And I've written a little bit about that, but in the present talk, I didn't mean to divide things up in quite that way. And I'm, you know, I think that some of what I said could be applied to black and white pictures and black and white movies. I think when we watch a black and white film, you know, the differences in lightness we perceive are assigned to objects in pictorial space rather than to the pictorial surface. There's surface awareness, but we're not visually perceiving the distribution of different lightness values across the screen. Those differences in lightness value, you know, go to objects in pictorial space. So it's kind of like scission without transparency perception. That might be a way of thinking about it. And I think you could have that both in the case of colored pictures and black and white pictures.
Okay, there is still time for a very quick question and a very brief answer. Enrico Terrone.
Thanks. It's a sort of follow-up to the previous question. I find it hard to see what's this experience of the picture surface as indeterminate with respect to color. since I think you agree that we experience the picture surface as determinate with respect to shape and size. It's a frame. So I find it hard to make sense of something determinate with respect to shape and size, but indeterminate with respect to color. Indeed, we have things that are have shape and size but no colors, and these are holes or window glasses. But can you elaborate a bit more on something that has shape and size, but it's indeterminate with respect to color? Thanks.
Yeah, so the idea there is that there isn't a distribution of color across the pictorial surface and pictorial space as you would have in an ordinary case of transparency perception. So in the case of watching a movie in a theater, we're not perceiving the screen as transparent to objects in pictorial space. The idea is that the visual system assigns all of the colors in the field of view to objects in pictorial space and simply doesn't offer comment on the screen. So there's information that specifies its distance and depth, its orientation, its shape and its size, but visual experience is simply silent when it comes to color. In the case of watching a movie, and maybe in the case of other types of naturalistic pictures. I have a paper where I talk about this more, and I do some additional examples that actually come from the philosopher Fiona McPherson, where we seem to be aware of form without being aware of color. She talks about type 2 blind sight in particular. I think she also talks about amodal completion as possibly involving something like that. So I think there are other examples that could be adduced, but I think this description is phenomenologically apt, and I don't see why the visual system couldn't do that. Why you couldn't have something like scission without transparency perception.
Okay, thanks.
Okay, so let's thank again our speaker.